Hello everybody and welcome to today's lesson on graphing radical functions. Today our objective is we will graph square root and cube root functions using a transformational approach. We have already used this transformational approach for our absolute value, our quadratic and our cubic functions. And that also works for square root and cube root functions. But first, let's go back to our quadratic function and see how we graph that one. Remember, we used our key values to get us started. 0, 0 is our vertex of the parent function at any rate. And then we go over 1 to the right, 1 up, 2 to the right, 4 up, and more is usually not possible on a coordinate plane anyway. And we go 1 to the left, 1 up, 2 to the left, also 4 up, and that will yield us our nice parabolic shape. The domain of any quadratic function is x such that x is an element of all real numbers, and the range depends on the vertex. In this case, it starts at 0 and goes all the way up to positive infinity. Then let's think about what the graph of our square root function, and here we have the parent square root function, will possibly look like. And the easiest way to do that is to get started is to create a table of values and think about what values are good values to start graphing. Now for our x value, we cannot use any negative numbers, right? Because the square root of a negative, by now we know that we can solve it using complex numbers, using I, but that's not something we can graph. So for graphing purposes, the radicand, remember the expression underneath our square root symbol, our radical, can never be negative. So let's start with 0. If x is 0, the square root of x is also 0. If x is 1, the square root of x is also 1. Now, if we want to avoid irrational numbers at this point, the next good number would be any perfect square, the next one being 4, and the square root of 4 is 2. And that's already very good to get us started for our graph here. We got the points 0, 0, 1, 1, and 4, 2. And that means that we will have a curve that's going to go like this over to the right. Our domain starts at 0 and goes to positive infinity, and so does our range. And that's why I'm using interval notation. Look at those two graphs and spend a minute thinking about how are they related. And when I mean how are they related, I want you to think back all the way to Unit 1 to something we have discussed back there. Spend a minute doing that, and we will come back to that later. Okay then, when we want to discuss how to graph a cube root function, let's also go back and remember how we graphed our cubic function. Our function f of x is equal to x cubed also had really 3 key values that we needed for our parent function. That was the origin 0, 0, then over to the right 1 up, 1 to the right, the point 1, 1, and 1 to the left and 1 down would be our third point. And the next points, both to the right and to the left, would already be way up or way down there. So that means we don't have a straight line, even though these 3 points may suggest that. We have a curve that wiggles through the x-axis, and then our next point will be somewhere up there, but on the second grid line to the right or left. The domain of our cubic function goes from negative infinity to positive infinity, and so does the range. Okay, so for our cube root function, let's again use a table of values to give us an idea where we're going to go. Cube roots, again, will be irrational numbers most of the time, unless we use perfect cubes. This is what we're going to do here. -8 is a perfect cube, and the cube root of that is -2. Cube root of -1 is -1. The cube root of 0 is 0. Cube root of 1 is 1. And the cube root of 8 is 2. And that gives us plenty of points to graph, actually more really than we can show on this coordinate plane. We have the point 0, 0, the origin yet again, then 1 to the right, 1 up, 8 to the right, which doesn't even fit on this coordinate plane, but I'm going to do it and estimate it just to give us a sense of the general curve. 8 to the right and up 2 would be here. Now we're going to the left, 1 down, 1 to the left, 8 to the left, and 2 down, just so we realize this is, again, not going to be a straight line. It will be a curve wiggling through the origin, and there is our curve for the cube root function, parent function at any rate, and our domain is again -infinity to infinity, and the range is also -infinity to infinity. And now looking at these two curves, I'm again going to ask you to think about how are these two related? What can you say about these two shapes of a cubic function and a cube root function? Remember, we discussed this concept in Unit 1. Have a look at that, and we will discuss it further in class. For our transformational approach, let's recall the different parameters that had an influence on the shape of any curve. And for this quadratic function here, f of x is equal to 2 times the quantity x plus 3 squared minus 1. Remember, the 2 we called a. Then we have h, actually the opposite of h inside our parentheses. And we have k on the outside. What did A do to our graph? Remember, A is what we called the dilation, and the dilation stretches or shrinks the graph, but it also flips it sometimes, and that is when A is a negative number. H leads to a horizontal shift, in other words, left or right, and it's always in the opposite direction of the sign. That's why we said it's actually negative h up there in the parentheses. And k leads to a vertical shift, in other words, up or down. So let's graph our first function here. It's a cube root function. Remember, for cube root functions, our 3 critical values would be for the parent function, the origin, then the point 1, 1, and the point -1, -1. So instead of using those points, the number in our radical is -1, so h is 1. That means we go 1 to the right, and k is 3. We go 3 points up. That is our first point. And since our dilation is 2, instead of going 1 to the right and 1 up, our next point is 1 to the right and 2 up, and 1 to the left and 2 down. These are all the points that we need at this point. Remember, this is not a straight line, but it's a curvy line going kind of like this. The domain of this function goes from -infinity to infinity, and the range also goes from -infinity to infinity. Okay, let's move over to our next example. This is a square root function. There is no index, and remember, if there's no index, we always have square roots. Let's set up our coordinate plane, and also remember what would be our most important points for our parent function. Would have been the origin, then the point 1, 1, and the point 4, 2. These we have to change now using our transformational approach. H is -2. That means we start 2 to the left and we go 3 down. So here's our first point. Our dilation A is 1/2. So when we go 1 to the right, instead we only go half a step up, and then we go 4 to the right, 1 up, and those are the points we're going to use for our graph. And this is what the graph will look like. So the domain now starts actually at -2 and goes to infinity. The range starts at -3 going to infinity. How could the domain start at a negative number? Well, we had the +2 underneath our radical, so -2 plus 2 is 0, and so we're still taking the square root, not of a negative number, but of 0, and then going from there of all positive numbers. Our function to the left is another cube root function. So we start off under the radical. We have no h, so we don't have to go to the left or right, but we do go one step up because k is 1. And now we have an a which is -3. So not only is the dilation 3, but also we have to flip. Instead of going up, we go down, and instead of going down, we go up. So going 1 to the right, we now go 3 steps down. Going 1 to the left, we go 3 steps up. And these are the points we're going to use for our graph, which will look something like that. The domain, yet again, from -infinity to infinity, and the range also goes from -infinity to infinity. And for our last example of the day, we have a square root function again. So for our square root function, we go 3 steps to the right, but we don't have to go up. And our dilation is positive 3/2, or positive 1.5. So we go 1 step to the right and 1.5 steps up. And for 4 steps to the right, we would have to go, instead of 2 steps up, we would go 3 steps up. Again, we're off the grid already. That happens fast. And here is our square root function. The domain starts at +3 and goes all the way to positive infinity. And the range starts at 0 and also goes to positive infinity. So that's how we graph square root and cube root functions with a transformational approach that we have used already in the past for other types of functions. For your summary, I want you, again, I said it earlier, think about how is a quadratic function related to a square root function, and how is a cubic function related to a cube root function, and jot down some thoughts in your summary section of these notes. That's it for today, and I will see you in class.